So, and then in the discipline of financial risk management. So, in my talk, I'm basically going to that that's the point here about that. So I'm going to introduce what is really happening and looking at the model that we're going to adapt in order to model this new benchmark rate. And then we're looking at how to once we come up with the model, and you have a model parameters that we need to estimate from the data. And then I'm also going to look at some empirical studies, and then I'll look at the conclusion. But what is really happening? It started with the global financial crisis of 2008. And during the global financial crisis, there was some global benchmark rates that are called LIBOR, meaning the London Interbank investment grade are willing to learn from each other. And this rate, before the global financial crisis of 2008, these rates were classified as risk-free. But it was during the global financial crisis, it was actually now people have come to see that LIBOR is not actually risk-free. And also during the year of 20,
manipulate the rate at which they are willing to borrow the unsecured fund. So there was, since then, there was a global shift from all jurisdictions to move away from using LIBOR-related instrument or rate as a benchmark. LIBOR is like in the US, and in each country, there is a LIBOR-related. South Africa in particular, there is what we call the JIBAR. The JIBAR is what we call the Johannesburg Interbank Agreed Rate, or sometimes they call Johannesburg Interbank Average Rate. And that's the JIBAR. It's a rate at which banks are willing to lend unsecured funds from each other. And this is actually derived from the negotiated certificate of deposit. There is 5 banks in South Africa who contribute to this JIBAR computation, and these are Investec, Standard Bank, Nedbank, FirstRand, as well as ABSA. Those every day they give the rate at which they are willing to borrow unsecured funds from each other, and then the Reserve Bank of South Africa, they compute this based on trim average. That means they take out the 10%, the top 10 and the bottom 10, and they average the middle 80%. So because of the global shift from using, because also JIBAR has been it's sort of like a judgmental rate. It's a rate where you ask FirstRand, for instance, at which rate are you willing to lend unsecured fund? It's an indicative rate. It's a judgmental rate. So meaning it's not transactional based. And JIBAR is actually forward looking because it's only depending on the forward period. So because of this global move, moving away from LIBOR related like JIBAR, South Africa also follows suit to actually move away from JIBAR related instrument to a new risk-free rate. And this risk-free rate is what we call ZARONIA. This is the South African Rand Interbank Average Index Rate. And this is now the ZARONIA that we are going to talk. I will going to explain further more on that. But the problem we have with ZARONIA is that unlike JIBAR is forward looking, and ZARONIA is now backward looking. So it depends on the actual transaction on the wholesale funding market. That means it actually it's a appropriate risk-free rate because it represents the actual transaction of all the contract on overnight basis. So that means there is actually an organization that's called International Organization for Security Commission that actually regulates the nature of the risk-free rate benchmark in the world. And actually, JIBAR doesn't fulfill some of the conditions, and then ZARONIA now, because of the volume and the sufficiency and the stability, as well as the transparency, now the JIBAR or the ZARONIA is now replacing JIBAR by the year of 2026. And the Reserve Bank of South Africa is now the administrator for this shift from JIBAR to ZARONIA. And this is what we're going to look at. But okay, well, why is it really important for us to look at this new risk-free rate? Okay, well, most of the financial contract instruments and also like loan, for instance, are indexed on JIBAR for long dated, maybe even 10-year, even the contracts that are even expiring in 10 years time are already indexed to like JIBAR. But JIBAR is coming to an end next year. So that means, so the contracts that were already in place, now they are going to be based on new risk-free rate, which is ZARONIA. That means there will be sort of like a value transfer. There is also a basis risk because JIBAR, for instance, is a term rate, while ZARONIA is just overnight rate. So that means you must be able to calculate the risk that involves from moving away from one rate to another rate. And also the fact that if you look at the 3-month JIBAR, for instance, about 30 trillion rand of contracts are indexed on this JIBAR, 3-month JIBAR. So that means it's a huge amount of money that already indexed or linked to JIBAR-related instruments. So that means we need to know how we can carefully be able to compute the new contract from pricing point of view, valuation of financial contract, and then now also to look at from derivative point of view, how do you calculate, say, for instance, caps, floors, and swaptions that are now indexed on this new benchmark rate that's called ZARONIA. And this is what I'm going to talk to you. And how do you come up with a model in order to model the new ZARONIA? So that's what I was saying, that there's a loss. Many people are lost because now they were asking themselves about how do we calculate this? What are the mathematics? What new mathematics that we need to implement in order to deal with this new risk-free rate or this new benchmark rate? Actually, many of the jurisdictions, they came up with a law of being able to regulate this new benchmark rate. Every country, most of the developed countries, South Africa is the only emerging economy that actually also follows suit in the whole. I mean, if you look it up, South Africa now, they're also replacing JIBAR. They're just following suit like in Japan, in US, and also in for instance, in Europe. Yes. So I'm going to look at that. This thing is quite quick. Okay. Well, I've already defined what is JIBAR. So JIBAR is the South African. So it stands for Johannesburg Interbank Average Rate. Then this is the South African benchmark based on negotiable certificate of deposit, and this is the rate at which big banks in South Africa, 5 of them, they give to the Reserve Bank and also Johannesburg Stock Exchange, and then they compute the average, and then the average of that is now the JIBAR, but there's also term related, maybe 1 month JIBAR, 3 month JIBAR, up to 12 month JIBAR. And like I said, this is calculated by the SARB using rate from 5 major banks. And ZARONIA, this is a measure of interest rate in rand-dominated overnight wholesale fund with minimum risk. And with that minimum risk, that's what we call is actually a best benchmark for the risk-free interest rate. And again, I would just say ZARONIA is a South African rand overnight index average. And this is now the acronym for that. And this is based on unsecured overnight deposit call that's placed among the commercial banks. And ZARONIA, like I said, this is calculated on a volume weighted and also using a trim average, meaning they take the 10% out and the bottom 10%, and then they calculate the average of that. And so the fact that also ZARONIA is based on the transaction rather is on the transaction of the contract or the volume. That means ZARONIA is actually not indicative, or meaning it's not judgmental rate like JIBAR. Okay, well, since so they in South Africa, so usually LIBOR transition started around 2018, but in South Africa they took a slow step to start. Actually, they started in 2022. In end of July is when they started publishing the amount of contracts that are benchmarked on this new risk-free rate, and already you can see it averaging about 433 billion of South African rand. Those are the instruments that are based on this ZARONIA instrument. So ZARONIA, the Reserve Bank of South Africa actually proposed different types of new benchmark that could potentially be the best candidates to replace the JIBAR. And ZARONIA was one of them. There was a horse race, and ZARONIA actually was now adopted as a new benchmark for South Africa. And ZARONIA will become very popular in the next few years to come. So what they did, the South African African Reserve Bank, they tested the ZARONIA from both. Like I told you, there is an international organization for security commission that govern that set out the principles that underlines or that accurately regulate the nature of the benchmark instrument in each country, and ZARONIA was approved to be the best risk-free or benchmark instrument for South Africa. And if you come end of this year, or actually next year, in the second quarter of next year, there will be no more JIBAR that will be published, and then the new risk-free rate will be the ZARONIA. So, like I said, South Africa are progressing well. And so progressing well, that means the Reserve Bank of South Africa, they host conferences and workshops to educate the financial industry in South Africa to make sure that every financial industry, they contribute toward the transition of moving away from from JIBAR to a new risk-free rate. And the education here is quite important because every single market player, they need to make sure that they're involved in order to have a smooth transition. You don't want only up next year is when now you're trying to re-evaluate your financial contract when it's already too late. So, and so the Reserve Bank of South Africa, they set up a different committee, and these committees are called the Market Practitioner Working Group, that are actually, each committee has different responsibility to make sure that they involve into theoretical foundation for ZARONIA. Like for myself, I'm involved into derivative committee, that just to give sort of advice and theoretical foundation on how you can price derivatives that are now based on ZARONIA. And also, so the goal, like I said, ZARONIA is to create a transparency because it's based on actual market data and also stability and also in alignment to the global practice, because the global practice is to move away from all these rates that are more judgmental, that I can actually judge. I can ask Zurab at which rate you want to, and then Zurab, because you want to be seen as a healthy man, then say, no, okay, I'll give this rate. And then we want to make sure that there's a transparency, and that's why we are moving away from. So again, JIBAR does not meet the International Organization for Security Commission, and this is the organization that set out the principles that regulate the nature of the benchmark rates in the world. And because one of the principles is a sufficiency, meaning the volume of JIBAR-related contract were also going down, just like LIBOR. And in that case, because the volume is below the level of what's been approved by the International Organization for Security Commission, and in that way, especially this I actually said it here, the sufficiency. And also now, ZARONIA provide reliable and transactional base, and it's a backward-looking rate. And in that case, so we're now moving away from JIBAR to ZARONIA. Okay, but the question is, if you look at the spread between, and then I'll come back to this, the spread between JIBAR and ZARONIA, it actually represents a lot, because JIBAR, there is a credit risk component that's attached to JIBAR, because JIBAR is not risk-free. Because now, how do you model the, meaning the additional spread between, because now JIBAR is always higher than ZARONIA, and the spread between the two, meaning it may be risk premium or credit risk or any types of risk, say for instance liquidity risk, that embedded into JIBAR. So now, how do we model this spread? And then I'm going to, because I'm a mathematician, so I'm going to construct a mathematical model to be able to model this this spread, and for us to have a forward-looking view how the spread looks. And this actually, from here, you can actually give an advice to a policymaker about future decision about their investment. And this is what going to. And again, okay, before I go to that, this is the step or the timeline that have been taken by the Reserve Bank of South Africa. So last year already, they invited me to one of the conference that was held in Johannesburg, and this is what it was called the MPG conference, and that was held in okay. Oh, okay, that was held in 2024 in almost July. And so here is when we see that, okay, well, they also this year they introduced what we call the ZARONIA derivatives, and the derivatives is quite very important, because the derivatives, everyone knows the derivatives is a financial instrument whose values depend on another financial instrument. So now this is quite important, because derivatives are used to mitigate or to transfer risk from one entity to another entity. It's actually very important, and it played a key role during the global financial crisis. And also it's very important for you as a market maker to be able to remove risk from your side and then give it to another to another entity. And these are the use of derivatives, and that's why I'm saying I'm most involved into this derivatives committee to be able to reformulate the mathematics behind behind this new rate. So at second quarter of next year, there will be no new JIBAR, and of course here at the end of next year, completely the JIBAR stop being published. Okay, so what are we trying to do? Like I said, because of course I won't just give a talk that doesn't have mathematics, because I mean I want to my research is about if about introducing new mathematics to deal with new risk phenomena. Risk phenomena is something that happened because of what's happening in the financial market. So now we have seen that there's now a new risk that comes because of a transitioning from JIBAR to a ZARONIA. Now, how do you model this risk that comes? It can be either value transfer, it can either be the basis risk, it can be either credit risk, or either the liquidity risk that involved, because now we have a liquidity issue here because of the volume of the ZARONIA, and we want now to be able to model this risk. So we consider a spread between JIBAR and ZARONIA for a 3-month tenor. A 3-month tenor is like every 3 months. That's the tenor that we're going to concentrate in this paper. And then, like I also told you, like a 3-month JIBAR, the amount of contracts that are indexed on 3-month JIBAR alone is about 30 trillion rand. So if we actually a 3-month JIBAR is the most popular benchmark rate or tenor in South Africa. So we must be able to model this, because come next year, when JIBAR come to an end, then now we need to be able to model all these financial contracts that were already in place, maybe long dated contract up to say 10 years. How do we model this spread? Then we use what we call the Cox-Ingersoll-Ross model. It's a very popular model for the interest rate because it doesn't allow interest rate to go negative. It's a mean reverting process, and it's a stochastic process. Stochastic process not mean that it can be able to model the randomness of the financial market. And then we also explore the potential future exposure with this now, the 3 months spread between JIBAR and ZARONIA. And then we model this actually via Monte Carlo simulation because we don't have closed form solution to them. And then we also now analyze the persistent volatility and potential counterpart risk. Counterpart risk is when you borrow money from an entity, and then your counterparty are unable to fulfill their financial contractual obligation, and then now you are faced with counterpart credit risk. Okay, the model. Okay, so I've noticed that we have people from education and psychology here, but I mean, you're fortunate you have a glimpse to understand some mathematics here. So we consider an affine processes that is defined on a filtered probability space. And a filtered probability is a sample space of all the events in the financial market. This one is a sigma algebra on that sample space. And then you have this one here is called the filtration. It's the one that gives you information whether a process is adapted or not to that to this filtration. And then P here is normally the probability. In this case, I'm using the real world probability because I want to do the estimation. And the probability is the one that actually gives you the probability of an event happening or not. Then we consider a stochastic process. Sorry. This thing is quite quick. Okay, we say a stochastic process because I mean it depends on it's actually a sequence of random variables, and we call it X. And then X is a time inhomogeneous conservative Cadillac Markov process, and then you exist, so there exists some function phi and psi that you can able to write their moment generating function in this way, and then that's what we call the affine process. So you have a process doesn't, and then another coefficient of X here, and that's why we say this process is an affine processes. Okay, and again here you can define your function into this derivatives here. And where F and R here, I didn't give the specific form, but they're given as a Levick intent type functions. And for those that are doing at least from mathematics, I think you can able to see these functions quite clear. Okay. Yep. Then Okay, so we consider a Cox-Ingersoll-Ross model. This one here is a stochastic differential equation. It has, why is a stochastic differential equation? Because here you have a diffusion, and we say that this is driven by a Brownian motion, here. This is a drift and this is a diffusion, and then we add a jump processes, and jump processes are governed by a Poisson processes, which is given here. And this term here is just given here. The kappa is the one that gives you the rate at which the process revert back to the mean, and the mean in this case is mu. And here is the volatility of the volatility. Because you have a square root here, it prevents the process going to negative, and that's good. And these are the nature of the parameter. And the first condition here is actually given as Feller condition, and the n is the Poisson process. Sorry guys, this one is a Poisson processes that can accommodate jump in the process. Of course, you can, or you will see in the figures that of LIBOR or JIBAR, ZARONIA, it represents some jump. So we are able to estimate a jump from the data, and then we're able to fit this model perfectly. And we assume that the jump process are independent with the Brownian motions, and for us to be able to model this very or pretty easily. I'm not going to go through the mathematics too much, but I'm going to give you the basic understanding of the model rather. Okay, well, we write the model like this. This X, this one is just the model just before the jump, this one here, and then we add the jump. And then, then now we can able to discretize it because we want to simulate this using Monte Carlo simulation, and with this discretization. And then this one is a jump adapted scheme. And then again, now we can rewrite it in this way. And this process again is just a process just before the jump. And then, so now we implement the process via Monte Carlo. And now how do we estimate the model? Estimation of the model, that means how do we find this parameter here? Oh, okay, so this model has a parameter kappa, mu, and the sigma normally is a volatility of the volatility, normally this one here. And then we also have the jump. How do we estimate this? First, we need the data. Once we have the data, how do we estimate the model? Meaning we need to fit the model to data. And then once we fit the model to data, then we can able to analyze the future exposure or credit risk embedded into this spread between JIBAR and ZARONIA. And this is what I mean. So, first of all, we define the transition probability, and we define by P. And again, I think this must not bring confusion with the probability. It's just a transition probability. And then we rewrite our process in this form, this still Cox-Ingersoll-Ross model. Then we write the characteristic function of the Cox-Ingersoll-Ross model. And again, this is pretty simple. Again, a third-year student can able to, we teach this to our third-year students. And because we said that this is the characteristic function just before the jump, because the jumps are independent with a Brownian motion, then we can able to couple the jump characteristic, the characteristic function of the jump, and this is coming here. Yes, this is the characteristic function of the jump. This is the characteristic function of Cox-Ingersoll-Ross model. Because of independence between the Brownian motion and jump component of the Poisson process, and then we're able to couple it like this. Very nice and easy. And then now we can, if you have the characteristic function, you can able to find the density, and then we can able to find the density in a closed form solution. And then here, but this you have to solve this the ODE at every particular transition days. You have to compute this density, and then we can able to find the cumulative moment generating function. And okay. now I think they can able to see, so maybe I must use this rather. Okay, so at every transition date, you have to solve this function in order to get you, and then to get you, of course, you can able to implement this at every point in time so that you can able to solve that transition density. And then because the jump component is actually very, it has a lot of calculation need to be done. In order to do that, you numerically evaluate the jump component, and this is how what we have done to evaluate that jump component, and then we establish the algorithm now in sort of closed form solution for the transition density, and this is given here, and I think it's just numerical manipulation, nothing really difficult here. But first, once we have the data, we need to detect the date at which we have jumped in the data. So what we did, one of the contribution of this research is we formulate algorithms that are enable us to detect the jumps in the data. And this is what follows. So what we did, so we have a time series, and this time series now the spread. We find the difference in the spread, and then we take the positive spread and the negative spread, and then we construct up a set of all the positive spread, or the positive spread, and then we construct up a set for the negative spread, and then now we find the difference between these two sets, and then we define another threshold that we call phi, or theta rather, and then we want now to solve this theta, which is a threshold, and then we solve this a threshold that actually maximize the difference between these two sets. And then at every date, again, we need to solve that threshold. And then now to detect a jump, we now go and we find the increment, we find the sum of the the sum of the delta x ti and the sign of delta x ti or xtj plus 1. And then we find this s. If s is positive, there's no chance of getting a jump at time tj, and then otherwise, then we continue looping through, and then now we also find the absolute value of the jump, and that's how we find the jump. And the algorithm, we actually summarize it here, and that the jump components are given by the sign of the change in the xi multiplied by the minimum of the absolute value of the change in the xi, and xi plus or xj plus 1. So that's the algorithm that we found. And then the estimation, of course, because we want to estimate, so you want to find the product of the transition density at the product. You use the log, you apply the log, the product becomes the sum, right? Yeah. This one here is a product, and if you find the log of then the sum becomes the product becomes the log, and then what we want now is to maximize this. To maximize this, because now most of the computational languages are more on the minimization, so you have to multiply this by negative, and then now you minimize. Then, so how do we do? So these are the algorithms that we have applied. So first of all, what you do, we fit the ordinary square approach to estimate the parameter for the Cox-Ingersoll-Ross model. These are kappa, theta. These are kappa, mu, and also volatility, the 3 parameters. The next parameter that we need to estimate is the jump parameter. And then from there, this one we get it from the ordinal least square estimation. So we use those estimation as an initial input to our algorithms that we have established for the transition density. So first of all, we initialize the parameter using the parameter established from the ordinal least square estimation. Then we use the jump detection algorithm in order to find the jump time in the data. Then once we do that, we compute the frequency of the jump, and which is called the lambda. And then from there, we continue to compute these phi I. These are the characteristic of the jump component. And then phi 1 is the first derivative of the characteristic for the jump, and phi second prime here is now the second part, second partial derivative of the, because these are actually quite important. They are needed in computation of the transition density. And then at every point in time, we need to solve U, like I said, and every transition date, we need to compute the partial derivatives, and it must be equal to y, and what you solve it, and then now at like that, then you can able to solve this log likelihood, and then to solve that, this one actually, you need to, we want to maximize that, but now because like I said, many computational languages are more on minimization, then you multiply that by negative, and then you minimize it. So now you want to solve, you want to find the parameter of the model that maximizes the log likelihood. Now, in this case, now you do it the other way around. You want to find the parameters of model that minimize the negative of the log likelihood. Yeah. Then now you got data. So we got data from the Reserve Bank as well as from Bloomberg, because ZARONIA only started in 2022 in July, but we needed a long time series for the ZARONIA. We partner with the Reserve Bank of South Africa. They gave us the proxy for ZARONIA. Already, they started already producing some sort of a proxy for ZARONIA in 2016. And then this proxy, we add the ZARONIA already from, so we actually have data from 2016 up until last year, 30th of August last year. And then this is the ZARONIA. This JIBAR, of course, we can get from Bloomberg. And then, so it's a 3 months. We concentrate in 3 months because we want to make sure we are able to fit our model to the spread between ZARONIA and the 3-month JIBAR, because the 3-month JIBAR is one of the highly it's a popular interest rate benchmark in South Africa, because like I said, about 30 trillion rands of contract are indexed on this instrument. And then come next year, if we don't have an approach of being able to see how is the risk profile for this transition looks like, then we are unable to make a well-informed decision of being able to say, should we invest or into this contract, or how do we going to look at pricing derivatives that are based on this 3 months JIBAR. Okay, well, first of all, then we look at this is the descriptive statistic, of course, because then you can see that the mean of the JIBAR is always higher than the ZARONIA, and then the spread of actually the mean of the spread is actually about 44, and then also the p-values that already that mean, and also the 75 quantile or the 25 quantile is also given here. Then if you look, the ZARONIA, yeah, this thing is quite sensitive, but sorry, just have to go back. Yeah. Yep. Okay, well, this is now the ZARONIA. Of course, you see from early 2016, then of course you have a jump. That's why we have adopted a model that can able to accommodate this jump. And then the JIBAR 3 months is the one in red. And then the spread is this one here. But of course, you can already see there's a jump in the spread. First of all, what we want to fit a model that can accommodate the jump, because if you just fit a normal pure stochastic differential equation without jump, then you are unable to be able to fit this spread. So we adopted a model that have jump, or that can accommodate jump, in order for us to be able to model, to have a process that can model these jump processes in the data. Okay, well, and then we define what is the potential future exposure, and this actually PFE is to measure the counterpart credit risk. The counterpart credit risk is when you have a counterpart and the counterpart is unable to fulfill their contractual obligation, and then now we want to measure, then this is how we measure. And where we, in this case, the PFE is actually very common in credit derivative instrument, but now in this case we're doing it on linear instrument, and this is what we're going to do here. And where this U of RT is a market to market value of the position in the ordinary linear financial instrument. And linear financial instrument, in this case, I mean the spread between JIBAR and ZARONIA. Okay. Okay, now what we do, we estimate this using Monte Carlo simulation, where we discretize our process and be able to simulate the process. Okay, first of all, to estimate the parameter, so we find the threshold. That's a threshold. We first of all, then you find the threshold. Then in the spread between JIBAR, so we found out that they are about 700 and in the data that we have about 470 jump that have been detected, and then this is the lambda, which means it's the intensity of the jump. And in ZARONIA itself, already you can see that there's quite a lot of jump in that data. We're about 655, and these are the parameters that we estimate from the spread JIBAR and ZARONIA. And also you can see the standard errors here is pretty simple. I mean, small. That means the effectiveness of the estimation procedure, but just not sure. But I have to double check again this one, why it's quite big in that case. But yeah, I will double check that. Then again, if you see, this is now the spread, and then all this circle part here are the jump. Like here, instance, when you have we detect a jump on that particular day. Then of course, then you take the spread. This is the observed spread, and then we fit the model to the spread, because of course, first of all, because this Monte Carlo simulation is not a closed form solution. Every time you simulate, unless you seed your simulation so that you don't generate new random variables, then you can able to have the exact fit to the spread. But I mean, here you can see that the model spread also the model spread here also exhibit the jump process. Then again, now here we simulate the jump, that JIBAR, and then we also have a model. It's not as precise, but I mean, of course, it follows the trajectory of the JIBAR. Then this is again the ZARONIA, and again it's like you see a step function in the observed data, and then again here in our model we're able to see this. It's not quite exact, and again the reason why it's not exact is because when we fit the model, and then we have to use this model to simulate using Monte Carlo, unless you see the random number generation, so that it use the same number of, or it's use the same random variable, the one that you fit the model, then in that case you can have a perfect fit. But what we're looking at more, to have exactly the same sort of trajectory as the observed data in this case. And this is now the result from the potential future exposure. That means already if you are standing here, we can see there's quite a lot that is going to be lost through over the years if we don't model this this spread very carefully. That means up until say 10 years, then you can able to see that the value will exposure from 30 say or from 27,000 or million up until almost zero in 10 years time. But this also means that a proper model like this Cox-Ingersoll-Ross, that model with jump, is actually able to be used for up until long-time contracts. And then again, here we use different scenarios. We use when you have increased volatility, when you have higher volatility in the financial market, like you have higher risk in the market. Increased volatility is this one, the black one. The economic shock, when you have like if you have economic shock, of course you can see that the spread now, this dynamic of the scenario analysis for the when you have increased shock, and then also when you have lower mean reversion speed. If you kappa is the one that actually measure the level at which the spread revert back to the mean, and in this case, if we have lower mean reversion speed, and we also expect sort of the sensitivity in the spread. Yeah, and this is just what I explained here, that we have a base case scenario. The probability that the spread will widen is 19%, and the probability that it will narrow is about 80%. Then scenario one is when you have the probability that the spread widen is 20%, while the of narrowing is, so the scenario are given now. This is the scenario one, this scenario two, and then this is the scenario three. And then in scenario three here is when the spread widening is actually about 22%, and this is when you have like the economic shocks in this case. Yeah, so that's what we've looked at. So our contribution in this case, we adopted to model the spread between 3-month JIBAR and ZARONIA. And the reason that we adopted the 3-month JIBAR is because the 3-month JIBAR is the most popular benchmark tenor for the JIBAR, and we must make sure that we are able to model this spread between JIBAR and ZARONIA, because come next year, when the JIBAR is no longer being published, and then we must be able to manage the spread between, because most of the value, there's a value transfer to a new contract, and this new contract are now going to be linked to ZARONIA. And also, we have introduced new algorithms to be able to detect the jump in the data. And then also, we have also proposed a new methodology for being able to estimate the parameters of the model via Monte Carlo simulation. Then we also look at the profile for the potential future exposure that has with the spread between JIBAR and ZARONIA. And then we can already see that if you model the spread between using a proper model, then you can able to minimize the exposure based on the risk profile of the of the volatility of the model. I think I will just stop here, but I always have a bonus to share. Now also I'm sitting in the editorial board for the Journal Futures Market, and this is the Q1 journal, and we want papers, higher quality papers in futures, derivatives. If you have as an ambassador for this journal, I would want you guys to, if you're doing research on derivatives or any related to future research, consider sending papers to this journal. And also, I'm also an associate editor of International Journal for Theoretical and Applied Finance. And again, it's a very good journal, and it's one of the respected journal in financial mathematics. And I would advise that you send. We always want higher quality research in financial mathematics, or something that apply mathematical method to solve a problem in applied finance. I think I'll stop here, and I'll leave enough time for questions and discussion.
Thank you very much for fantastic talk. I hope there's some questions from the audience. We'll first ask questions from the audience over here before we go online. Any questions? Zurab.
Well, first of all, congratulations for the editorial membership on these two very good journals. If you could please go to page 40, slide 40, I mean. The shape 40, this is 41, I think. So the shape of the observed data, the red one, right?
Yeah.
That one seems to have this step feature. Now, the model doesn't have that feature. Is it not possible to implement this step-like behavior in the model?
Yes, you cannot. You can add a step behavior function in the model.
And what is the reason that it hasn't been added?
Yeah, because because we just fit a pure jump processes, which is based on Poisson process, and maybe that could be the reason that we can't see the steps here in this case.
So is it a good idea to fit the steps?
No, I mean, what you want to do is to have actually a model that actually follow the observed data.
Right.
Yeah.
Okay. Thanks.
And again, again, most of this fit is actually based on because the fit first you estimate the model parameter, and then you simulate another process to be able to fit to the data. Because of your new generation of random variable, that could be the sources of not having exact. Yeah, and again, most of that is also depending on if you add a step function in this into our model, then you can able to see the steps. Yeah.
Thank you. Question back there.
Have there been other models proposed? And if so, how do they compare to yours? And in particular, you want to get the red and the black close to each other.
Yeah.
So have you got some kind of measure that says this is the effectiveness of my model?
Thank you, Prof. I think that's a very good question. Most of the models that have been proposed are just the model that accommodate the jump processes, and most of the so far most of the models that have been proposed, the jump components are being driven by the monetary policy rate, meaning people go to the central bank calendar and look at the announcement dates of when the central bank is going to do the announcement for the repo rate to see whether they increase the repo or not. And then they look at those announcement dates, and then they consider those announcement dates to be the one driving the jump in the model. So instead, we have used a different approach. Our approach is rather than to go to a calendar or what we call the scheduled jump from the monetary policy calendar date, we rather look at the spread of between JIBAR and ZARONIA and then infer the jump from the spread rather than just putting as a jump to be an input of the model. We infer the model from we infer the jump from the data, actually from the data that we have, and then we now have the jump time that have been inferred or estimated from the model. And so when compared to, we haven't really tested or compared to how does this model perform compared to the scheduled jump component. And this is one of the aspects that we want to do, and before sending it to another to a journal. Yeah, I think that's a good question.
Thank you. Other questions from the audience? Well, I have a question. So you've developed the mathematical framework and applied it to the South African data. To which extent is your framework applicable to data in other countries with other ways of doing things?
Yeah, that's also a very good question, because I mean, the scope of South Africa definitely is very limited, but of course our model can be applied to any data, like so US data, for instance, is also very applicable, and that's why we want our next extension is to be able to to even widen the scope of our framework so that we can show that this framework can be applied in any environment, just not in South Africa or emerging economy, for instance. Yeah.
Are there any questions from the online audience? Oh, there's one question here.
Thanks, Prof. I'm not a mathematician, so is it just an artifact in my mind that does it look from that figure that model either consistently underestimates or overestimates? It looks like from the previous graphs, or is that just me making it up in my mind? It seems like the model is always consistently lower during non-volatile times, or it's consistently higher in volatile times. So that's my first question. My second question is practically, let's say I'm the Reserve Bank, well, not me personally, but let's say the Reserve Bank or some other financial institution wants to use this. Is there something that prevents them from using this kind of model? Are they restricted by legislation after 2008? Are they, we know that in many cases they're limited by sort of backward models just to make sure that the whole financial industry's got uniformity. Is there any restriction to using some very nice, elegant model where they'd rather go back to some back of the envelope?
Yeah. No, thank you, Prof, for the question. I'll answer the last one first, and then the first one. With this, we have seen that our model always consistently underperform compared to the data. And again, what we want to investigate further to see if we use schedule current date for the monetary policy, if maybe we have something much better. Maybe there's just something we are doing which is not right here. Maybe so that is some extension that we are currently doing to see to really robustly or to test our model in a robust way and also do robust check to see why our model is underperform or underestimating the data. Then with the use of the model to like in South African economy to implement this nice model, actually, like I said, I'm involved into the derivative committee, practitioner working group for the derivatives. Definitely, my aim is to make sure that I convince my colleagues to be able to use some of these models. But I mean, it's not a trivial exercise because I mean, you must make sure that the model is well tested to be able to be applied in practice. So there's a number of things that need to be done. We want to make sure that we test this complicated or this nice model compared to the benchmark simple model, like say, for instance, like simple like Wassercheck model for interest rate, for instance, very simple, no jump. And we have to also establish the importance of having jump in our model, but because that is always empirically, it's important to have jump in the model, but is it really important for people to apply a complicated model rather than just using a simple? And that's what the financial market practitioners are not mainly interested. They're interested in using a very simple model to do a job rather than having a complicated model that doesn't have a closed form solution for implementation. Yeah, but that's something that we're looking forward to see if we can convince the practitioners to be able to use some of these models. Yeah, thank you.
Thank you. I see somebody online has raised their hand. Can this person ask the question directly, please? You're welcome to speak. Hello?
Yeah.
Are there any other online questions?
Yeah, there's two here. So why should banks determine the rates rather than the Reserve Bank?
Okay, that's a question. So the nature of how JIBAR was established. JIBAR is a rate at which the big banks in South Africa. Like I said, it's Standard Bank, Nedbank, Absa, Investec, and also FirstRand. Those are the credit wealthy bank in South Africa, the big five. Then what they do, they have been asked a question every day. At which rate are you willing to lend unsecured funding? And then each bank actually come up with a rate, and then they submit to the Reserve Bank, and the Reserve Bank actually take the 10%, top 10%, the bottom 10%, and then calculate the average. So that is the nature of the JIBAR by the formulation. Yeah.
Okay, and then there's one more. Can you please discuss the risk of moving from a rate with a risk premium embedded JIBAR to a risk-free rate like ZARONIA?
Yep. Okay. Well, how JIBAR was established is JIBAR has a risk component. Then now ZARONIA doesn't have any risk because it's an alternative risk-free rate. Now the whole idea is you have contracts that are already indexed on JIBAR that are ending, say, in 20 years or 10 years. Now, how are you going to model that credit component that was already embedded into the JIBAR because the ZARONIA is risk-free? So now there is what we call adjustment spread that has to be added to ZARONIA, and then the adjustment spread is now what we're going to deal with. How do you calculate the term component in ZARONIA? How are you going to, in order to be able to model properly or to evaluate the financial contract or the loan that are now going to be benchmarked on this ZARONIA? And that's why it's quite very important.
Thank you. If there are no other questions, let's thank the speaker again.